All right, what is virtualization? Virtualization, in a nutshell, is I have one piece of equipment, one server, one workstation, one mainframe, one whatever, and I'm trying to make it run other things on top of it. So what happens in your traditional, so let's rewind back 10, 15 years. You had your one server in the office and basically just did one thing. Some people would try and make it do multiple things. It's really not virtualization. You're just making this one poor server do more and more work. Virtualization lets us do multiple systems. So whereas before, if you had your one file server, one domain controller, one application server, you can now have that one server with separate pieces inside of it. So you could have this little virtual machine be responsible for Active Directory. This one in charge of your file and print sharing. This one is your SQL server. This one is a terminal server. And the nice thing is you can treat each one of these as an individual server. So if you shut this one down, these guys aren't affected. So you get a little bit more availability depending on what you're trying to do. And there are more fun things you can do with one server or multiple servers, and all working together to run all those virtual machines. So it's you start getting a little bit more out of your hardware, and I've got some more numbers later on what you can actually get out of them. There are a lot of different hypervisors out there. Hypervisor, when I speak virtualization, that first layer that talks to the hardware or allows the other virtual machines to run under them, those are your hypervisors. Microsoft has one, VMware has theirs, Oracle, Linux has KVM. Xen is actually what Amazon Web Services use for their virtualization. Parallels, if any of you have Macs and you run a Windows installation on your Mac, odds are you're using Parallels. Works pretty good. And I looked at the list of them available 2 or 3 years ago, and there was like 20 more. There's a lot of different choices, and each of them have their own benefits, drawbacks. You look at something like HyperV. HyperV is built into Windows Server. It's free. You just tell Windows, run Hyper-V, you're done. You don't have to pay any extra licensing for the ability to do that. You just go to town. VMware's, this is one that you have to start paying for. ESXi is actually their free product. So anyone can go register with VMware and download a copy of ESXi. It's a very good hypervisor. It's just very limited compared to ESX. ESX is your full-blown, you could do lots and lots of crazy stuff with, but you pay for all of those extra features. And you may or may not actually need those features, and this is where talking to your favorite IT company can steer you in hopefully the right direction on what you're looking to do. I've dabbled with VirtualBox too. Actually, our backup solution that we use for a lot of people relies on VirtualBoxes, how it brings up virtual copies of for disaster recovery. So it's a pretty good product. KVM, I know a friend that he loves that. Xen, like I said, it's Amazon, and Amazon is not a small product, so it does pretty good. So the reason why you're probably here, why should the small, medium business care about virtualization? The first thing, more bang for the buck. The first picture I showed where you've got one server that has the ability to run multiple server, and there's some tricks with, or not tricks, but there are some things about the licensing that actually make more sense too. In the Microsoft world, if you buy one copy of Microsoft Server, you are entitled the right to use 2 virtual machines under that one license. So you effectively get 2 servers for the price of 1. So you're getting more out of that dollar you're spending. Scaling, easier scaling. So if you have a hypervisor and you want to add more to your environment, say you need to double the amount of servers you have, well, it's pretty easy. Because everything's virtual, it doesn't care the hardware that you have. You throw down some new hardware and you can either start migrating stuff onto the other one, or you just start spinning up new virtual machines. And the virtual machines do not have to do anything with the host system. They can be, as I've done virtual machines of Windows 2000. Steve and I worked to get Windows 95, 98, Windows 2000, XP, Vista. We had all of these virtual machines running on one hypervisor.
Windows 3.1
yeah.
too, I think.
Yeah, and Windows 3.1, that's right, and a little DOS box. So yeah, we had all of that stuff running. It doesn't matter the hardware you're really using. Increased system availability. You can certainly increase your system availability if you want to spend lots and lots of money. There are some features that will make it so if one physical server dies, everything is just moved over to a working one faster than that. You never know anything's wrong. You pay for that feature though. There are other redundancies where you can set it up where you don't have that instant flip over. You can set it up where one physical server is replicating all of its virtual machines to another one. And in the event the first one dies, you walk over to the second one, really make sure the first one's dead, and then start up all those virtual machines on the second one. Not instantaneous, and you could probably automate it, but you don't want to. So you do have some more options there. I've had to do that for a couple places, and it's literally a 5-minute right-click start, and you're done. Your redundant server is up and working for you. Disaster recovery, DR. So now that everything is just virtual, there's no hardware really bound to it, you can send these virtual copies pretty much anywhere. You can send them to a USB drive someplace. You can send them to a network drive on the other side of your building. You could send them to your other building over a piece of fiber. You can send them to the cloud. Microsoft has their Azure services, and you can very easily just tell your local server, replicate to Azure, and you have a DR option. So it's pretty easy to do that kind of stuff. You do have to pay a little bit for those features, but you have them. It's how much do you want to try and how much is it worth keeping the option and going. So hardware optimization. I mentioned we've got multiple servers running on one physical machine. That one server, years past. This is a example of a computer that we monitor. This particular computer, this is a graph of the processor. You'll notice it's hanging pretty much 8% all the time. This is a 20-30 person company. This machine does all of their file shares. It does authentication for them. It runs their ERP software. I mean, the lifeblood of the company runs on this server. And the thing's sleeping most of the time. So they are not necessarily getting the most bang for their buck out of this hardware. They might have overspec'd that a little bit. So I started digging through the rest of our graphs, and this was a system we had in the office, and this particular one was running Hyper-V. It had 6 or 7 virtual machines running on it at the peak, somewhere over here. And you can tell that processor is pretty much working all the time. If you look at the other graphs like hard drive usage, memory usage, they're all equally, everything's way higher. So that particular server, we were using a good portion of it. Perhaps overusing it in some instances, but like I said, then this is actually a newer server, probably 2 years old. This was a 5 or 6 year old server, and it was doing more than this one ever would. So you're making more use of the hard drives on there, because most of the time a hard drive just isn't doing a whole bunch, processor isn't doing a whole bunch. Someone buys a server with a whole ton of memory. Well, most of that's sitting idle, so you're wasting a lot if you're not virtualizing stuff. Migration simplification. This is actually probably one of the biggest things we notice with dealing with people in the small business. A lot of places they have a older server. This thing's 5-10 years old and it's going along. And how do you handle that upgrade to the latest and greatest? With virtualization, it actually becomes a lot simpler. Because we remove the hardware aspect of the server, we can actually take an old server, virtualize it on new hardware, and we don't have to worry about the thing dying anymore. So that hard drive that's been spinning dutifully for 10 years, well, we don't have to worry about it not spinning the next time we reboot the server. If you are already running in a virtualization environment, it's very easy to take that VM that's running on one system, turn it off, move it to another brand new hypervisor, turn it on, and away you go. They barely know anything's happened. So your downtime is really just the copy over. And again, depending on the hypervisor and the options that you buy, you don't even have to have downtime for that. You can just tell a server, go to that piece of hardware. A couple seconds later, you're done. Software, this is actually really nice, and I've done this a couple times for people, and I think as a company we've done it for a bunch of people. So software testing. Again, because everything's running virtual, we don't really care what happens to it. We have other copies of the software. Most virtualization has the ability to take a snapshot. So it's basically taking a picture of that server or whatever that's running virtual, and we can go back to that picture anytime we want. So what's the greatest case for that? XYZ company wants to upgrade their ERP system or their QuickBooks installation or their whatever installation. They can take a snapshot of their server before you start the upgrade, do the upgrade, realize 3/4 of the way down the upgrade path, oh, nothing's working, go back to that snapshot. Never happens. You roll back to whatever your snapshot was, and it's like nothing ever happened. So you have this great ability to test things prior to pushing them out in production. You can also test things like Microsoft updates, the Windows updates as they come down. If you want to, like say, every second Tuesday of the month, Patch Tuesday for Microsoft, you can download all those to your test machine, run every application you want to, put it through its paces. If it works, put it out to production. If it doesn't work, well, figure out what's wrong. But you haven't affected your production environment yet. So you give yourself a little bit of leeway and security. And this makes a little bit more sense for the like software development places. So the ideal situation for a software developer, something like that, you have a dev environment, you have your test environment, you have your production environment. I've seen it where companies have the dev and test are the same thing. I've seen it where test is different hardware than dev. If you can virtualize all that stuff, you have complete control over the environment you're testing in. So your dev environment, you can spin that up. You have your devs do whatever they want. Push that over to a test environment, test it over there. If it doesn't work, roll back to a snapshot. If you need 20 new test systems to work with, assuming the hardware will do it, tell the hypervisor, hey, let's turn on 20 new systems. Let your dev and QA team go to town on them. When you're done, turn them off, and it's like nothing happened. But it works out pretty good, and you got a lot of control over what's going on with them.
What's a good example of a company that would not get a good return from using virtualization?
I guess the smaller a company is, the less likely they're going to be a candidate for virtualization. Some of the stuff I mentioned with the like migrating off to a new setup or testing or whatever, that may not make too much of a difference to them. So you do have to spend a little bit more to get virtualization up and running, a good virtualized environment. That may or may not be worth it. But as you start getting a little bit bigger, any company that has 2 servers or has the need of 2 different servers, virtualization is just where you really want to go, because you're not buying 2 physical boxes, having to worry about 2 physical boxes failing. You would have the one system, and like I mentioned before, with the 2-for-1 Microsoft licensing, you get 2 servers for your 1 license running virtual. So that XYZ company who needs 2 servers, you only buy 1 license. So it does. Very, very small companies, not as much needed, but the bigger you go, the easier it is to justify it. Increased uptime technologies, clustering, live migration, vMotions. This is kind of what I hinted at before. You want your servers up. You want the files available. You want the application working. Things like clustering, live migration, and vMotion help you to do that. This clustering and vMotion, actually this is the Microsoft solution, or vMotion's the other, is the VMware one. That is where, again, if a physical machine doesn't work, you can instantly transfer everything that physical machine was doing onto another host. So no one knows anything happened with it. Yeah, and the DR, so you can send your off-site replication. And if you subscribe to things like Azure, you can not only send a copy of all of your data up into Azure, you can run your copy up in Azure. You will pay for the amount that you're using, but you have that option. So if your entire facility was not working, you could very easily, like say the building burned down, flooded, whatever. You log into your Azure console or portal, tell it, fire up my replicated VM, and you're up and running. So it works out pretty good from a DR standpoint. And actually, to have a server up in Azure isn't that much money. Steve and Bob were working on cost. It's for a very, very basic server, it's what, less than $100 a month? Yeah. So just to have the data up in Azure is pretty inexpensive. If you need to use it, then you start getting billed for how much you're being used, specifically the bandwidth going back and forth. And then there is some cost for the processor, if I remember right, how much you're using.
When it's when you add processors, because you max it out, like the $15 is probably about as powerful as this laptop, and they go upwards of $400 or $500, and that's it is what you pay for. It's the same idea, and then you pay for bandwidth, however much storage you transfer back and forth, and then you pay for the storage itself, the amount that's sitting there.
So, yeah, you have options. So, like Bob likes to say, we are in a solution-rich environment, and there's no shortage of solutions. Of course, there is always a gotcha, no matter what you do. There's no such thing as a free meal. Because you have you could potentially have a bunch of virtual systems running on a server. If you try to use poor hardware, too slow a processor, not enough memory, not enough hard drive space, the wrong kind of hard drive space, those errors up front can dramatically impact all the virtual machines down the road. If you don't put enough processor in there and you try and make each of your VMs solve folding proteins, well, that whole system is going to just cry because it can't do everything at once that you want it to. There's not too many people are going to fold proteins, but
So in other words, you can't make a silk purse out of a sow's ear.
Yes. Another big thing that you really need to make sure when you're setting up a virtualization environment is your core networking environment can handle all of this extra traffic. A lot of places will just use very inexpensive switches because, well, they work. You plug something in and people get stuff. When you're dealing with a server that's trying to funnel multiple virtual machines through it, you're going to start paying the price on lower end equipment. So this is a bit of a cost. I mean, it doesn't have to be a huge amount, but it is a cost that you really should put in if you're going to use virtualization on a ongoing basis. Anymore, I think Steve and I spec no less than 4 network cards on any system, and in reality, most network cards are used, or most servers have 6 or 8 in them, and that's because you need that many interfaces to push data around. Well, if you have 2 servers and there's 8 ports in one of them, you're going to plug that into one low-end switch. Everyone's going to be crying, why isn't this moving? Why is everything so slow? Why does it take so long to load things? You got to have a good switching environment to go with your a good hypervisor solution. Overutilization of hardware, I mean, this is pretty easy to do. If you've had a HyperV server or ESX server going for a number of years, and every now and then management comes up to you and it's like, I need another machine to do this. Okay, but the hardware won't run it. Yes, it will. Okay, fine, I'll do it. You start leaning on that system too much, and again, the performance of everything else on that system is going to start taking a hit. Processor is usually the big one. Really, the biggest bottleneck is going to be the hard drives that are physically running the system, and where all those virtual machines sit. And, I actually found some numbers for like common hardware of what the hypervisors use. And it's very easy to overuse those pieces of equipment.
Would a solid-state hard drive be appropriate in that situation?
Usually, yes. And that's part of the numbers I've got on the next slide. Something else you need to make sure of, your runaway train. So what if you have a couple servers virtualized on one piece of hardware, and for whatever reason your application just goes haywire? It uses up every drop of memory and processor and hard drive space it can get its little hands on, and again, that's going to take down or at least impact everything else running on that system. You have to make sure to put your checks and balances in place to not allow something like that happen. I've seen plenty of cases in specifically older setups, people never put those checks and balances in. So you've got one VM that for whatever reason brings everything else down at lunchtime when someone runs a report. Well, you can go in there and limit these kind of things, but for whatever reason people very rarely do. So you really want to make sure that you spend some time, and it's the setup for looking over the entire environment where you're trying to deploy virtual machines, and make sure that you don't let anyone do that. Licensing. I love you, Microsoft. Who, by the way, sponsors part of our lunch. Licensing can get very, very crazy, very, very quickly in virtualization. So your copy of Windows that you go get with a computer from Best Buy, you can't virtualize that. That's actually against the usage rights for that license. Yes, you physically can, but you have to buy a different license for it. You get into the case of what's known as virtual desktop infrastructure, where no one really has a computer, and you've got all of these workstations running on a virtual machine. You actually have to have usage rights for that. And again, your retail box copy of Windows doesn't work. That's not a compliant license. You have to have a volume license version of Windows. And then other things like if you were migrating a server from physical to virtual to carry it on in the virtual world, most people would buy a server with what's known as an OEM license. That is a license from Dell or HP or IBM or whoever, and that is bound to that hardware. Well, when you virtualize it onto something else, you don't have that license anymore. Again, yes, you physically can, but you need to follow up and buy your volume license or other appropriate model licensing for that system. So you're adding more things to check and pay money for, unfortunately. And it's one of those you really have to make sure to dot the I's and cross the T's as you're going forward with a virtualized environment. This was actually just some kind of cool numbers that I found for virtualization. So there is a unit of measure for basically everything a human being ever does. Virtualization, we use the metric of IOPS, input-output operations per second. This is how much can a server do at any particular time. The biggest bottleneck is usually the hard drive. So I looked it up. Your standard desktop hard drive gives you about 100 IOPS per second. This is your Best Buy computer. Go to Newegg, get a consumer grade drive. That's about what you can do. It's pretty respectable, but if you have a lot of people accessing it, it doesn't work. Or it might not meet your needs. A server class hard drive, about twice as much. This is actually like a 15K RPM drive. It does a pretty good job. Your standard desktop SSD, you notice there's a lot more zeros after the end of that. And that's because there's no physical parts anymore. I don't have this little hard drive head moving around a piece of magnetic material trying to find the data I'm looking for. It just does it at the speed of light. Almost at the speed of light. Does this mean you want to put standard desktop SSDs in your production servers running Hyper-V or ASX? Maybe not. Your standard desktop SSD isn't designed for the long-term abuse that a server is going to give it. They have a shorter lifespan. On an SSD, there's actually little physical spots where you're writing the data, and they can only be written to so many times. And you'll burn them out real quick in a server environment, potentially. Also, the average mean time between failure is a lot lower compared to server class SSDs, which, again, we keep adding zeros. And there are bigger ones with more zeros. So the price difference, let's say you go with a 1 terabyte drive up here, $70 Newegg, $60 Newegg right now. Server class hard drive, 1 terabyte, I don't think you can get that big, but something comparable, about $300-400. This guy, again, for a decent size, like 240 gig, is something fairly average anymore. I think those cost $140, $150 for a good one, $180 for a really good one. This guy, you could buy a block of East Cleveland. I believe this this was a Fusion IO Octo, and its price tag was about, for the low end 5 terabyte version, was $100,000. So you can see the scale as performance increases, price increases exponentially. But if you need this many IOPS, you can pretty easily justify and probably have the bank account for $100,000 piece of equipment. This gets into your Cleveland Clinics and massive SQL databases and Oracle databases and other very, very high-end stuff. Most of the time, your average business can get away with using the low-end enterprise-grade SSDs and the faster traditional drives. They're you can play games with the hard drives. It all depends on how you configure them. Again, going back to configure it right up front versus just tossing them in there and see what happens. You can get a good number of IOPS out of a standard hard drive when it's configured correctly, and have 50 people beat up the server and no one will notice the difference. Same with the SSDs, and there's even new technologies out there where you can have a very small SSD, buy your 100 gig, 200 gig, a very small one as far as the server is concerned, and you put that in front of the cheaper hard drive storage and you make them work together. You end up with just a massive amount of data that can go between the hard drive and the SSDs and then out to the end users. I think Steve and I both have been playing with the tiered storage, and some of the stuff he has set up is just ridiculously fast compared to your average setup. It works out pretty good. It's known as tiered storage. The biggest thing about virtualization, and Bob likes using this quote all the time, you've got this one server running multiple things, and Mark Twain, as he put it, you can put all your eggs in one basket, just watch the goddamn basket. So, again, that absolutely is appropriate for what's going on with this. This is where you really want to make sure to use the replication technologies, your disaster recovery options. Make sure you have a backup. Make sure you test your backup. That's more important. Yeah. I've seen too many places where they have backups up and running and never test them. When they go to use them, what do you mean we don't have anything? Well, make sure you have the stuff up and running and you're testing it. We are a Microsoft shop. We do specialize in Hyper-V. That's what we use. Like I said, it's built into Windows, so Windows Server, so we don't have to worry about any of the super extra costs behind it compared to ESX or ESXi. It works out pretty good, and at this stage, Microsoft has been doing some catch-up with VMware as far as technology and options and things you can do, and they've gotten pretty much to the same spot where VMware is. So all of your features you can do in VMware, you can do in Hyper-V. The only unfortunate thing is there's less documentation about that. There's not as many people doing it. VMware has been the leader for years and years, so there's a lot of people doing it. So odds are you're not going to be the first person who has done whatever you're trying to do. Hyper-V, you might be at the front of the pack if you're trying to do something special. So it's where we go, and you get into things like SQL and Exchange. How you set up Exchange and SQL and applications on a virtualized environment is very different than you would on just a standard bare metal system. You have to take a lot more into account, specifically where your data is being accessed. I mentioned the slow speed of those hard drives. You want to make sure you use high-speed hard drives for the high-speed virtual machines. Yeah. I could start rattling on about a whole bunch of other things, but...
Ladies and gentlemen, Kevin Dukavic.